So I'm going to talk about regular expressions a bit, and I'm just going to kind of start with the Wikipedia document. It tells us that regular expressions are just a sequence of characters that define a search pattern. The concept arose in the 50s when American mathematician Stephen Kleene formalized the description of a, quote, regular language and came into common use with Unix and text processing utilities like ed and grep. So some of the basic concepts are you got kind of a Boolean, like an OR. You can group things together. Quantification, like how many times a particular character is going to occur. And then you've got different characters that just represent, say, a number or a string, a particular just alpha character. And then there's a couple of different types. So we have a file here called test, and I just threw a few names in there. So I'm going to use egrep to kind of search through this file. I think we've gone over regular expressions a little bit in previous breakfast bash videos, but this is just a little more about it. So I want to find everything with ed in it. So I'm going to just search for ed in test. So it found Ted. I want to find anything that has ed or So I want to use the or operator, the Boolean operator. I found Sherry and Ted. I could do use like a question mark, I think, and that gave me more than I really wanted. Why did that not work? It doesn't matter. So usually a question mark, in like bash, is going to say so in bash that's going to just expand to this file test.txt, but I can't remember exactly what question mark stands for, so I'll just not teach you about that. So there's different types of regular expressions as well, like different standards. So you've got POSIX, you've got extended regular expressions, and others. So we'll go over that in a slight detail in just a minute. But let's say I wanted to find everything with a let's go test 4. So I want to find anything with a digit. So here's an example of oh geez, what is it called? Kind of a set of characters. So I'm going to do 0 through 9. So find me anything with 0 through 9, and it found those two. And I want to make sure that it has a B after it. Well, happens to be that both of those say B. So the $ is the end of the line. If I were to put that $ there, and in bash you might want to be careful about whether using single quotes or double quotes. or in any language really, that's going to try to interpret your dollar sign potentially as a variable. Usually your delimiters in most languages, you can specify a delimiter to make sure that it's interpreting the string as a regular expression and not as a variable. A very common delimiter is the double slash. Let's see. So that doesn't work with egrep, but like let's say we did use sed. We use delimiters there to separate our search from our replace and our options. So this is just saying replace any number with, let's say, z. Notice that the z here was replace the number that was there. You could do in this set of characters, you could do A through Z. You could do capital letters A through Z. You could do just a particular letter. You can do dashes. Any of your special characters you want to put at the end of this set of characters here. And I believe you'll probably want to escape any dot. Dot usually represents just any single character. And notice that it only replaced just the first instance. A lot of times your options of your regular expression or your search function or command is going to just match the first instance unless you otherwise tell it. Also, it's only going to match, it's going to be case sensitive unless you tell it. So let's back that up. ZI, BZI. I think with set I need to do test. I don't know why that's not working. Anyways, so some of the characters that are there, your caret represents the very first character in a string. Your dot is any single character. Your also your dollar sign is the very end of the line. Let's see. In terms of quantity, you could look at, let's do our egrep again. Let's look for any line that has 2 R's. Actually, 1. Alright, so it found that. Let's see if it'll find 2. And it does. 3. Alright, so you could also do, so this is saying I need to find at least 3 R's. And I didn't find that in the case of Sherry. I could also do 1 plus repetition counts. Oh, there you go. So 1 comma is going to be 1 until an infinite number. Another way you could do that is a plus sign. Or if you wanted at least 1 R, but 1 or 0 or more R's, you do the star, the splat. So it found everything because everything had 0 or more R's. Alright, so regular expressions are very useful. Let's see what I forgot to tell you about the not. Alright, I don't want anything. If you want to exclude certain characters, you can use a set of characters with it beginning with a caret. So I want anything without an R in it. And of course, this is just a very simple example. So this was everything that didn't have an R but did have a Y. Or ed. You can start getting more and more complicated. Question mark actually matches the preceding element 0 or 1 time. I talked about the question mark earlier. In the context of regular expressions, matches the preceding element 0 or 1 time. So there's also these character classes, which you'll be familiar with like TR, where you could say alpha plus. They all have some alpha character. This is just kind of the same as doing A through Z, A through Z. There's various character classes that I won't go through all of them. Digit, lower, punct, like special characters, space. There's also, like I said, a couple of different standards. And one thing to mention in POSIX and BASIC extended, or sorry, in the POSIX and BASIC regular syntax, or BRE, your state or patterns that include the parentheses and braces need to be escaped with a backslash. Extended regular expressions do not require the escape of the parentheses and brace. Yeah. So, yeah, you should know about regular expressions, know how to use them in your favorite language, and they'll be very powerful for you. Thanks for paying attention.